Hi everyone, this is Milady Ordoneza, and for today's video, let's tackle about operations on integers. Operations on integer numbers. Integer numbers are whole numbers. This can be negative, positive, or a zero. When we perform mathematical operations of integers, we follow a different set of rules that are specific to the character of the number. Not every rule of mathematical operation applies to the integers. Let's see how handling integers are different from the normal mathematical operations. Integer numbers and mathematical operations. Mathematical operations include addition, subtraction, multiplication, division of any number. When we perform these operations with integer numbers, we always keep in mind the sign before every number. As we already know that an integer includes a number with a positive or negative sign, therefore, these have to be dealt with different perceptions. Before delving into further operations, we first need to know the properties related to these mathematical operations. Addition and subtraction of integers numbers. Property of closure in addition and subtraction. When we add two whole numbers, the answer is a whole number. This is called the closure property of additions. Now, do integers also follow this property? Let's see. For example, 10 plus negative 12 equals negative 2 is negative to an integer number since it has a negative sign with it. Therefore, we call it an integer number. From the above example, we can say that the sum of two integers is also an integer. So when an integer a is added with another integer b, the answer is always an integer. Okay, so let's take some more examples to support our observation. Example number 1, 19 plus 10 equals positive 29. 15 plus negative 20 equals negative 5.
In both the examples, the solution is an integer. Therefore, every integer when summed up with an integer gives an integer. So what happens when an integer is subtracted from an integer? Let's see the following examples. 10 minus 3 equals positive 7. 15 minus negative 7 equals negative 22. In both the examples, the difference between two integers gives an integer in solution. This means that integers are also closed under subtraction. Hence, in the case of subtraction of the two integers a and b, the answer to a minus b is also an integer. Commutative property. Commutative property states the following. A plus b equals b plus a. For whole numbers, we already know that the sum of two whole numbers is always the same. This means that integer numbers also follow the commutative property like whole numbers. Let's see the following examples. 15 plus 20 equals 35. Hence, 20 plus 15 equals 35. Negative 10 plus negative 5 equals negative 15. Hence, negative 5 plus negative 10 equals negative 15.
Those examples prove that addition of integers is commutative. In the case true with subtractions, are subtractions also commutative? The following examples will let us know this. 5 minus negative 3 equals positive 8. Negative 3 minus 5 equals negative 8. Are the integer numbers the same? The answer is no. This brings us to the conclusion that the subtractions of integers are not commutative. Therefore, a minus b is not equal to b minus a.
Associative property. According to associative property of whole numbers, ABC, a plus b times plus c equals a plus b plus c. Does this property also apply to integer numbers? So let's see. Negative 4 plus negative 6 plus negative 2 equals negative 12. Otherwise, negative 4 plus negative 6 plus negative 2 equals negative 12. The answer in both the cases is the same, so the sum of integer numbers abides the associative property of addition.
And let's go to additive identity. The additive identity of any number is checked with the help of 0. For all the whole numbers, 0 proves to be their additive identity. This means that when a whole number is added with a zero, the answer is the whole number itself. In the case, same with integer numbers as well. The answer here is a yes. The following examples prove our observation. 10 plus 0 equals positive 10. Negative 9 plus 0 equals negative 9. Therefore, for any integer x, x plus 0 equals 0 plus x. And now we have multiplication of integers. After addition and subtraction, we need to understand the multiplication of two integer numbers. Let's look at some of its properties. The first property is the closure property. Is the product of two integer numbers also an integer number? Well, yes. The product of every integer is an integer. The second property is the commutative property of multiplication. The product of two same integers is always the same. This means that a times b equals b times a. The other is multiplication with 0. Every integer when multiplied with a 0 gives 0 as a answer. Example, a times 0 equals 0. We have multiplicative identity. Every integer number when multiplied with 1 gives an integer number and an answer. Example, a times 1 equals a. Negative a times 1 equals negative a. Next is associative property. Integer number also abide the associative property of multiplication. This implies that like whole numbers, the grouping of integers does not affect the product of integers. Thus, a times b times c equals a times b times c. The next is distributive property. Here we shall check the distributivity of integers over addition is true or not. Negative 4 times 2 plus 6 equals negative 32. And the other one is equal to 32.
The example shows that multiplication of integers also shows distributivity of multiplication over addition. Thus, a times b plus c equals a times b plus a times c. And now, does the distributive property also comply with subtractions and multiplication? The answer is a yes. The example below will help you understand. Negative 8 times 5 minus 3 equals negative 16. And negative 8 times positive 5 minus negative 8 times negative 3 equals negative 40 minus positive 24 equals negative 16. From the above example, we can thus state that a times b minus c equals a times b minus a times c.
Multiplication of a negative and positive integer. As already said earlier, while performing the mathematical operations of integer numbers, we must always keep in mind the respective sign before any number. When multiplying two integers with an integer and positive sign, the product shall always be negative. This means that in every cases of multiplication between contradictorily signed integers, the answer shall always be a negative sign. Okay, so for example, 4 times negative 5 equals negative 20. To simplify the product, we write the above example as negative 5 plus negative 5 plus negative 5 plus negative 5 equals negative 20. Some more examples are this.
Therefore, negative a times b equals a times negative b and equals to negative a times b. The multiplication of integers is similar to multiplication of whole numbers. The only difference here is that after multiplying, we put a minus sign in the answer. And now, let's proceed to the multiplication of two negative integers. The multiplication of two negative integer numbers is always a positive integer. This means the product of negative a times negative b equals positive c. The negative integer numbers in multiplication are multiplied like ordinary whole numbers. Some examples will help you understand this in a better way. Example, negative 3 times negative 6 equals positive 18. And negative 30 times negative 15 equals positive 450. This means that negative a times negative b equals positive a times positive b. The minus sign of the integer numbers while multiplication is ignored.
Now, let's move on to division of integer numbers. We know that divisions are inverse of multiplications. How do we then perform divisions in integers? Division of integers is similar to the division of whole numbers. While dividing an integer with an integer, we divide like normal whole numbers and then put the sign respective to the integers involved. This means that when we divide a positive integer with a positive integer, the answer is always a positive integer. Similarly, when the division involves one positive and one negative integer, then we divide them like normal whole numbers and put a negative sign in the quotient. So for example, 72 divided by negative 8 equals negative 9. Negative 80 divided by 5 equals negative 16. Now let's look at the sum of the properties of the division of integers.
The first property is closure property of division. Is the division of two integer numbers also an integer number? Well, no. The division of two numbers does not give an integer in the answer. Say for example, negative 8 divided by positive 2 equals negative 4 and negative 9 divided by positive 2 equals negative 9 over 2. So the division of integers does not give an integer in the answer. The other one is commutative property of division. This property does not apply to divisions between integers. This means that a divided by b is not equal to b divided by a. The other one is division by 0. Like whole numbers, an integer number also cannot be divided by 0. But when 0 is divided by an integer, the answer is 0.
Next is division by 1. Every integer number when divided by 1 gives the same integer number in the answer. But the case is not the same when the integer is divided by negative 1. Example, a divided by 1 equals a divided by negative 1 equals negative a. From all illustrations, we have come to know that the mathematical operations of integer number involve cautious calculations as this follow a different set of rules. So once again, I am Lady of Ardeneza, BSed Mathematics second year student. Thank you for watching.